GPIO stands for General Purpose Input Output. It is a standard interface that is used to connect other electronic devices to microcontrollers. For example, it can be used with sensors, diodes, displays, and system on chip modules. It allows for providing the external power supply, remote control of connected devices, broadcasting more contextual data, or defining contents for custom Bluetooth data packets. These are the exposed pins along with the edges of the Tinker board. These pins are a physical interface between the Tinker board and the outside world. At the simplest level, you can think of them as switches that can be turned on or off. Of the 40 pins, 28 are GPIO pins, which are shared with SPI, UART, and I2C pins. The Tinker board is equipped with one SPI bus that offers two chip selects. The SPI bus is available on the onboard 40-pin header. All of them are numbered and have different functionality, which is expressed by a color directly under the pin. For example, 5-volt pins have a red pad underneath them, and the ground pins have a black pad. As you can see here, we have two options to refer the GPIO pin numbers. The first one as GPIO.Asus and the second one as GPIO.board. The GPIO.Asus numbers are not in sequence for the left as well as the right channel. So we will follow GPIO.board for the left channel. It follows the odd sequence. It starts from 1 and goes till 39, and for the right channel it follows the even number sequence which starts from 2 and goes till 40. So when you actually connect sensors to the GPIO pins, you can easily follow the even or odd number sequence.